So we should be able to get this done pretty quickly, I'm guessing.
Yeah. It's mostly just knowledge question. It's no math. It's pretty easy.
All right.
Yeah.
All right. So who wants to start with number 3?
I'll go ahead. The true linear regression equation is y equals b original plus b1x, where b original and b1 are unknown. What is an alternative hypothesis for b1? I got C.
C is what I got.
Okay.
Did he say C?
Yeah, he did say C.
Okay.
So why is it C? Sorry, I just was a little confused on this one.
If you look at the reading, you know how it gives you the. Oh, let me pull it up.
What up to?
Like the summary. That's right on the summary, and it gives you a little. So scroll clear to the bottom, and then it has a paragraph above it that explains why.
Okay. I see it. Okay. Number 4. The residual is. We have 4 options.
I got B.
The difference between the observed value y and the value predicted by the regression line.
That looks good to me.
Yeah.
Jason, do you concur?
I'm just reading here.
Yeah, I just found it in the reading. It's on that same summary.
Yeah.
A residual is the difference between blah 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 blah.
Awesome. Okay, number 5.
Let me get back to it. So we chose B.
Yes.
B as in boy?
For number 4, yeah. Jason was asking about
Okay.
number 4.
Bravo. Yep.
Okay.
Alright, then on number 5, who wants to read that?
I can read it. Plot of residual supports using linear regression when I think it's C, the megaphone shape.
I think so.
Oh, wait. What number are you guys on?
We're on 5 now, Josh.
Oh, 5. Sorry, I thought you were on number 4 still.
No, so yeah, Jason had just asked a question about 4.
Oh, okay.
I'm not sure on number 5.
I think 5 is C.
Number 5, I'm going to have to go to the textbook for that one.
I'm looking through it right now.
Where'd you find that, Jason?
In the video,
Oh.
the wedge player video. But it also says in the homework. It's in the answer key. It says the variance of error terms is consistent for all values of x, residual plot, and then it says no megaphone shape in the residuals. So the residual supports using linear equations when variance of error terms consistent for all. So, but it says no megaphone, and this is saying you see a megaphone, so it's definitely not C. So
Oh, okay.
I just proved that I am inaccurate.
That was solid.
So
So it's not C.
Are we still on number 5? Sorry, I can't hear too well.
Yeah, we're
correct.
5, and it's Jason
Okay.
found that it's not C.
Okay.
And we're all just looking back on the reading real quick to see if we can find anything.
Residual supports linear regression.
So from the reading in section 3, it talks about simple linear regression, and the plot of residuals. I'm trying to find the part where it talks about plot of residuals. Okay, residuals 3.2.
I know we reject the null if it has a residual shaped like a if it is shaped like a megaphone. That's when we reject the null.
Right. Um, okay, so it says that there are several plots that could arise in a residual plot. Or, I'm sorry, there are several patterns that could arise in a residual plot. And there's curvature, megaphone, and outliers. Curvature is when the residual plot shows curvature that suggests that the data are not linearly related. So the question using linear regression, so it's not a curvature. With a megaphone shape occurs when points tend to be close together on one side of the graph and further apart on the other side of the graph. If there is a megaphone shape apparent in the residuals, it suggests that the variance of the error terms is not constant for all values of x. It suggests that there is a difference in the spread of residuals depending on the value of x. So it doesn't say if that's linear or not. I guess I'm not really finding a pretty solid answer yet.
I'm just pulling up the textbook now. Have you guys figured it out yet?
No. We're still looking.
Alright, sorry, I've been dinking around in Excel.
Oh, that's okay. So Jason and Kelly, I actually found something here. I'm sharing my screen if you guys want to see.
I'm gonna go
I don't know if this is what we're looking for, but this might help a little bit with the question of linear.
Yeah, I'm looking at that same thing actually.
Okay.
Are you talking about the very top paragraph there? The QQ plot for the residuals of the crocodile data show a straight line. We do not have evidence of non-normality in the residuals. We conclude that the residuals are normally distributed.
Oh, I didn't even see that. I was actually looking at the table right here.
Plot residuals supports using linear.
But yeah, there you go. A QQ
A
plot.
straight line. So does that mean A, you see a pattern, or D, they look normally distributed with zero mean? What does that zero mean?
Yeah, it's.
I think it's A or D.
I don't know how you could have a zero mean. I mean, obviously, if you have positive and negative numbers. I don't know. Yeah, let's go with A. Yeah, we do.
So if there's a pattern in the residual, is that what you determined 5 is A?
Yeah.
Okay.
Is that what you found in the reading? Or were you just?
I can't really find the answer.
Yeah, we couldn't either.
It's kind of confusing. It doesn't really spell it out for you.
We had to dig deep, but yeah, I think we're going with A.
Okay, cool.
Oh, here we go. This residual plot shows random scatter. There's no obvious pattern in the data. If linear regression is appropriate, then the residual plot will show no patterns and will consist of random scatter. If there is a pattern in the residuals, it suggests that linear regression is not appropriate. So it's not the pattern one.
Oh, so it's not patterns.
So back to D.
So
That's reading under 3.3, right underneath the QQ plot.
Interesting. Then we have to find it by elimination. So.
Sorry, so for Josh, on number 5, we changed from A to, we're thinking B.
D is in Delta.
B is in Delta, yeah.
Okay.
Because Kelly just found something that said when there's a pattern, it can't be linear or something like that.
Right, okay.
All right, so number 6. It's kind of hard for Josh to read it, so I'll go ahead and go again. Compute the residuals for the math efficacy data using software. Use the confidence data as the explanatory variable and the score data as the response variable. What statement best describes the residuals?
So I went ahead and plotted these,
Okay.
and I think it's A, but we probably work through it together, but
How did you plot
they're
those?
not all negative, and
Did you
they don't
just
form a linear pattern.
Okay. When you plotted that, Josh, did you just use the quantitative procedure inference or whatever?
Yeah. And
Okay.
then just go to the linear regression tab,
Yeah.
and it's definitely not linear. It's definitely not. They're not definitely all positive. So
it's got to be A.
I think it's A, but if you guys want to double check me.
Did you guys hear that, Lisa and Kelly?
Yeah, I heard him.
Okay. So he said, he said that they're not linear nor negative, so he's thinking A.
So use.
But we can work through it if you guys like. I think it'd be good for us to work through it real quick.
Yeah. What? Use the confidence. Use the confidence data as explanatory variable. What's the Oh, I've got it. Okay. I'm just copying and pasting. 1 second.
Okay. And he said just to use the linear one.
Okay.
Linear tab.
Come on.
I don't have it pulled up right now.
Where do you click to change linear?
So there's several options at the bottom of Excel as far as like what sheet you want to use.
Oh, yeah, okay. I thought you were saying within linear regression.
Oh, I'm sorry, no, just which page to use. I think it's called linear.
Okay. You're saying it's A?
Yeah.
Residuals are between -40 and 25.
Does that formula spit it out and tell you the residuals as well, or?
I don't even know where the residuals would be. Confidence interval.
So Josh, on number 6, we're still Kelly was putting in number 6 on Excel. Does it show like what the residuals are within Excel?
Yeah. So when you paste in the explanatory and the response variables, it populates the residuals. And then you just highlight those and make a scatter plot. And on the scatter plot,
Oh, okay. So from the residuals that it gives you, you make a scatter plot.
yeah, so you highlight the residuals and make a scatter plot, and it looks like the values are around -40 to 25. Like you can just tell. And I know that I'm kind of doing the elimination game. They're not all negative, and on the scatter plot, it's not forming a linear pattern. But I don't know.
Did you hear all that, Kelly?
Yeah, I did. So do you have to make your own scatter plot, or is this one that's on the sheet supposed to do it for you?
So the one on the it's already there is doing, it's a scatter plot with the explanatory and response variable
Okay.
residuals. I think you have to create the residual.
So, okay.
So what you could do, Kelly, is you just highlight the residual column, and then there should be an option in the top of your toolbar to make a
Insert.
scatter plot of that data set.
Okay. Yeah. Yeah, that I agree with what he's saying.
Sweet.
I can share my screen so
Yeah.
that you can see what I'm doing. It should start screen sharing. There.
Yeah, we see it.
Okay, so I copied and pasted those from here, and then he's talking this. I thought this would do it, but and then I clicked insert, and then I did this right here, scatter plot, and then it showed up. Here it is right here. He said between 25 and -40. That's accurate.
Sweet. Okay, and so off of that scatter plot, or is that also known as a QQ plot?
Yeah, I think so.
Because for number 7, we have to say if it's not normal, right skewed, or fairly. And looking at it,
Not normal.
excuse me.
Yeah, it's not normal.
I don't know. Looking at it, looks kind of right skewed because most of the data is on the right, correct? Oh wait, no, sorry, that's the bottom one.
Yeah, this one here. The
You're going
bottom.
off the bottom one, right? Not the top. The top one, it would be right. It would be right skewed.
Yeah, but the bottom one with the residuals, I'm guessing that's just not normal.
Yeah.
But it's referring to the residuals. That's why we're saying not normal. Okay.
Josh, so for number 7, did you put not normal?
On number 7,
Yeah.
I put not normal.
Sweet.
Okay.
That's
We
what
agree
we got.
Okay, yeah. So, yeah, they don't show any pattern.
No, none whatsoever. Okay, number 8.
I can read this one. Use software to create a scatter plot of the math self-efficacy data. Give the scatter plot, residual plot, and QQ plot. Which of the 5 assumptions about linear regression are satisfied by the data? Check all that apply.
Okay.
So number 1 is definitely true. Because the scatter plot for the both variables is linear.
Okay. So
How does he know that?
No, B is false. The residuals are not normally distributed.
right.
We figured that out earlier. Yeah.
And then C, the variance of the error term is constant for all values of X. What does that mean?
I do not know.
What the heck? The X values are measured without error. What are the X values?
X values are your explanatory variable.
Oh yeah, so the X values are the confidence ratings. Are they measured without error?
I would say they were. I mean, because
Right, I would think so.
you get your Y from your X, so I don't know.
And then the observations are independent of one another, right? Or are they? Oh, I guess they're independent because they have a linear relationship, right? Well, I don't know.
Would that make them dependent? I don't know. Because if there's a linear relationship, that means that depending on your X value, your Y value is going to be staying constant. And then if they were independent, then there wouldn't be a linear relationship.
Right.
So I think the last one is not checked.
Yeah.
So I guess the only thing that we don't know is the third one, which makes no sense.
The variance for the error term.
So I'm looking at the chapter reading. It says the requirement of observations are independent. It says knowing the value of one of the y's tells you nothing about any other point. Is that true? I don't know. They're non-constants. So hang on. So for number 3, the constant variance, it says no megaphone shape in the residuals. And that is true. There is no megaphone shape. So C is the correct answer.
Okay. So we're going.
No megaphone shape. And then observations are independent. Knowing the value of one of the y's tells you nothing about any other points. I guess so, because the y variable, the score on the test, doesn't tell you about their confidence. But they probably got a higher score on the test.
But if they're linear, we decided they are linear, right? So that means they coincide. Like the lower the confidence rating, the lower the score is going to be.
Right.
So that would mean they're not independent. They're dependent upon each other.
So we're going with just A, C, and D.
A, C, D, yeah.
Okay.
A Charlie Delta. Alpha Charlie Delta.
Yep.
Alpha Charlie Delta.
Alpha Charlie. Moving on to number 9. It says, what is B1, the estimate for the slope? Can you look at your data there, Kelly?
Yeah, I am right now. Is it this one right here?
12.695.
12.695. And yes, that's what he got as well. 12.695. Sweet.
And the confidence interval, I put A, but the numbers aren't exact, but they're really, really close. The confidence interval spreadsheet don't match up like identically with the homework problem, but they're very close, 10.7, 14.7.
Okay. What did it pull up on yours, Kelly?
I'm trying to figure out where that. Oh, yeah, 10.6, 7.4, and 14.715.
I wonder why it's a tad bit off. That's odd.
So close. But if we both got the same.
Hopefully A, because of how close they are, but
Yeah.
So I am. Oh no, I'm getting different numbers for this. What B of O. Also, never mind.
Yeah, it's off barely. That's interesting.
I'd say it's A though.
Yeah, well, because we're going off of B of 1. So.
Yeah.
Great. All right, do you want to read number 11, Kelly?
Yeah, based on the evidence using significance level of 5%, what decision would you make regarding the hypothesis test for B1? So p-value, it's giving us, I'm getting the huge number, 3.3. Oh, but that's e to the negative 24th.
smaller than 0.05, so we reject it. B.
Yeah.
Alright, reject B.
Is that right?
Yeah. Yeah, it's B.
B boy. Yeah.
Alright, number 12 reads, for a hypothesis test for B1, the slope, if you reject the null hypothesis, what does it mean? It means that there is sufficient evidence to conclude that the slope of the regression line is not
0. So C.
You got it.
13 for the crocodile data, which variable is the dependent. I've got that pulled up. It's body length, right?
The body length, yeah.
Yeah,
Okay.
because it's second here if you're looking at my screen again.
Okay, cool. So, and then, so for that, like, the dependent's always the second variable. Well,
Yeah, and it says that here, I believe.
okay. All right, for number 14.
I'll read it. Since the 99% confidence interval for these data is whatever, you can say, what can you say about BF1? 7.
Well, there's only 3
It's
choices.
either A or B, right?
Oh, you said B. Sorry. Yeah, I think it's B.
Yeah, that sounds right.
Yeah, I think B.
Cool.
All right, let's see how we did.
See what we did. Okay.
That's pretty good.
Oh,
So just a couple back.
Freaking A. 14 and 8 and 7.
how did we get those?
Probably
How did we get number 7 wrong?
Yeah, clearly not normal. It was pretty obvious.
Maybe I was referring to the top one,
right.
the top chart instead of the bottom.
That isn't normal at all.
Maybe it's fairly normal because it kind of sits. Well, yeah, it kind of sits in a straight line this way.
I get it. Yeah.
Oh yeah, it's kind of a hot dog, right? Rather than a hamburger. Hamburger is a circle. Hot dog is regular.
Yeah, I guess.
I guess. I don't know.
Hmm.
And who knows? On number 8, we could have just missed one or selected too many.
They normally give you a percentage, not all or nothing.
Yeah. Whatever. It's done. Screw it.
All right. Well,
All right, guys. Good job tonight.
if you guys want to like get together and study for the final, we can always do that. I don't know how easy that would be over, the air or whatever,
Yeah,
but
isn't the group work Thursday like preparation for the last exam?
Yeah,
oh, okay.
Okay.
should be. That's what it's consistent with all what we've been doing.
Oh, yeah. Yeah, it is. It's just mark this activity complete for Thursday.
Cool. All right.
All right. Well, we will
All right, guys.
see
Good job.
you guys.
Yeah.
We'll see you Thursday.
Good night.
Yeah.